Welcome to Space Theory, the channel where we explore the mysteries of the universe. Today is our topic is should we abandon the multiverse theory? The allure of multiverse. Imagine standing at the edge of our universe, peering into the abyss beyond. What if I told you that beyond our cosmic horizon lies an infinite number of universes, each with its own unique reality? Welcome to the mind-bending world of the multiverse theory. This concept isn't just the stuff of science fiction. It's a serious scientific proposition that has captivated researchers and thinkers alike. But as intriguing as the multiverse theory is, it also raises a fundamental question. Should we abandon it? Buckle up as we embark on a journey to explore this fascinating debate with space theory. The birth of the multiverse theory. The multiverse theory wasn't pulled out of thin air. It has deep roots in the history of scientific inquiry. It emerged from attempts to solve some of the most perplexing puzzles in physics and cosmology. To truly appreciate the multiverse theory, we need to go back to the inflationary theory of the Big Bang. Picture the universe in its infancy, a fraction of a second, old and expanding at a mind-boggling rate. This rapid expansion, or inflation, could have created multiple separate regions of space-time, each evolving into its own universe. But that's not all. String theory, another cornerstone of modern physics, proposes the existence of multiple dimensions and an array of possible universes. In string theory, our universe is just one solution among many. The idea that there could be countless universes, each with different physical laws and constants, adds a whole new layer to our understanding of reality. The scientific merits, exploring the possibilities. Why should we even consider the multiverse theory? Proponents argue that it offers elegant solutions to several fundamental problems in cosmology. For instance, the fine-tuning problem. Our universe appears to be finely tuned for life, with physical constants set just right for stars, planets, and ultimately, life to exist. In a vast multiverse, it's not surprising that at least one universe, ours, has the right conditions for life. This perspective shifts the question from why is our universe fine-tuned to why wouldn't there be a universe like ours in a multiverse? Moreover, the multiverse theory could provide insights into dark matter and dark energy, two of the most mysterious components of our universe. These phenomena are not fully understood within the framework of our own universe, but a multiverse perspective might offer new ways to approach these puzzles. The criticisms, where evidence falls short. As compelling as the multiverse theory sounds, it faces significant criticism, primarily due to its lack of empirical evidence. Critics argue that because other universes, by definition, cannot be observed or measured directly, the theory remains speculative and untestable. This challenges the very foundation of the scientific method, which relies on falsifiability and empirical verification. Consider the analogy of a detective trying to solve a case with no physical evidence, only circumstantial clues. Without direct evidence, can the detective ever truly solve the case? This is the dilemma facing proponents of the multiverse theory. Furthermore, some physicists contend that the multiverse theory complicates rather than simplifies our understanding of the universe, introducing more questions than answers. Philosophical implications. The nature of reality. Beyond scientific debates, the multiverse theory also has profound philosophical implications. It challenges our notions of uniqueness and reality, suggesting that there could be countless versions of ourselves living out different possibilities in other universes. This raises questions about the nature of free will, identity, and the significance of our choices. Imagine a universe where every decision you make creates a new reality. In one universe, you chose a different career path. In another, you never met your best friend. Such considerations force us to ponder whether pursuing a theory with such intangible implications is a productive use of scientific resources. Are we ready to face the existential implications of a multiverse where every possible version of our lives exists somewhere out there? The pragmatic approach, balancing curiosity and feasibility. Given the current state of evidence, a pragmatic approach might be to balance our curiosity about the multiverse with the feasibility of obtaining meaningful results. While it's essential to push the boundaries of scientific knowledge, it's equally important to allocate resources to theories and experiments that offer a higher likelihood of empirical validation. Imagine a treasure hunt where you can only follow a few leads. Do you chase after the glittering but elusive clues of the multiverse, or do you pursue the more tangible trails that promise concrete discoveries? This does not mean completely abandoning the multiverse theory, but rather placing it in a context where it can be explored responsibly without overshadowing more testable scientific endeavors. The role of thought experiments, expanding our horizons. Thought experiments have long been a staple of scientific progress. From Schrödinger's cat to Einstein's elevator, these mental exercises push the boundaries of our understanding. The multiverse theory can be viewed as one of the grandest thought experiments of all. It encourages us to think beyond the confines of our observable universe and consider the broader implications of our physical theories. Imagine for a moment that you are an astronaut venturing into the unknown regions of space. As you travel farther than anyone has ever gone, you begin to encounter strange anomalies, signs of other realities interwoven with our own. This mental journey mirrors the explorations of theoretical physicists as they probe the limits of the multiverse theory. By embracing such thought experiments, we expand our intellectual horizons, even if the ultimate answers remain out of reach. The technological frontier, tools of discovery. Advancements in technology have always been crucial to scientific breakthroughs. From the invention of the telescope to the development of particle accelerators, our tools shape our understanding of the universe. The pursuit of the multiverse theory could drive the development of new technologies and methodologies, pushing the limits of what we can observe and measure. Imagine a future where advanced telescopes and detectors allow us to peer into the very fabric of space-time, revealing subtle hints of other universes. This technological frontier holds the promise of transforming speculative theories into testable hypotheses. By investing in cutting-edge technology, we keep the door open to potential discoveries that could validate or refute the multiverse theory. The cultural impact, shaping our worldview. The multiverse theory doesn't just influence science. It has a profound impact on our culture and worldview. It permeates literature, film, and art, inspiring creators to explore themes of parallel worlds and alternate realities. This cultural impact reflects our collective fascination with the unknown and our desire to explore the limits of our imagination. Consider the popularity of films like Interstellar and Doctor Strange, which delve into the possibilities of multiple universes. These stories captivate audiences, inviting them to ponder the nature of reality and their place within it. The multiverse theory, whether scientifically validated or not, has already left an indelible mark on our cultural landscape. The ethical dimensions, responsibility in science. With great theoretical power comes great responsibility. The pursuit of the multiverse theory raises ethical questions about the allocation of scientific resources and the prioritization of research. As stewards of knowledge, scientists must weigh the potential benefits of exploring the multiverse against the opportunity costs of not investing in more immediately impactful research areas. Imagine being part of a council deciding the future of scientific funding. Do you allocate resources to the tantalizing yet unproven multiverse theory, or do you focus on pressing issues like climate change, healthcare, and energy? This ethical dimension underscores the importance of responsible decision-making in the scientific community. the future of multiverse research, navigating the unknown. As we look to the future, the path of multiverse research remains uncertain but full of potential. Ongoing advancements in theoretical physics, cosmology, and technology will continue to shape our understanding of the multiverse. Researchers will need to navigate the unknown, balancing the pursuit of bold ideas with the rigor of empirical science. Imagine standing at the threshold of a new era in cosmology, where each discovery opens up new questions and possibilities. The future of multiverse research is not just about finding answers. It's about embracing the journey of exploration, the thrill of discovery, and the relentless pursuit of knowledge. A journey of wonder and skepticism. The debate over the multiverse theory encapsulates the essence of scientific inquiry, a relentless pursuit of knowledge tempered by rigorous scrutiny. While the multiverse remains an intriguing and intellectually stimulating concept, its current lack of empirical support necessitates a cautious and balanced approach. As our tools and technologies advance, future discoveries may shed new light on the validity of the multiverse. Until then, the question remains open, inviting both skepticism and wonder, and reminding us that the journey of science is as much about asking the right questions as it is about finding definitive answers. Extended content, deep dives into key aspects. To expand this script to 13,000 words, we need to dive deeper into each section, adding more detail, examples, and explanations. Below are the extended outlines for some sections. The birth of the multiverse theory, detailed history and developments. Inflationary theory, the seeds of the multiverse. The multiverse theory has its roots in the groundbreaking inflationary theory of the Big Bang, proposed in the early 1980s by physicist Alan Guth. The inflationary theory addresses several puzzling aspects of the universe's early moments. According to this theory, a fraction of a second after the Big Bang, the universe underwent a period of exponential expansion, growing at an incredible rate. This rapid expansion smoothed out any initial irregularities, explaining why the universe appears so homogeneous and isotropic on large scales. But how does this connect to the multiverse? Imagine the early universe as a rapidly inflating balloon. In this scenario, inflation can cause different regions of space-time to expand so quickly that they become causally disconnected from one another, effectively forming separate bubbles or universes. Each of these bubbles could develop its own unique physical properties and constants, giving rise to a multitude of universes within the broader multiverse. Evidence supporting the inflationary theory comes from observations of the cosmic microwave background, COM, radiation, the afterglow of the Big Bang. The uniformity and slight fluctuations in the Keem align with predictions made by inflationary models. These findings lend credence to the idea that inflation could be a valid mechanism for creating multiple universes. String theory and M theory, a multidimensional perspective. String theory, one of the most ambitious and complex frameworks in modern physics, provides another potential pathway to the multiverse. At its core, string theory posits that the fundamental particles we observe are not point-like objects, but rather tiny, vibrating strings. The different modes of vibration correspond to different particles, elegantly unifying the forces of nature under a single theoretical umbrella. However, string theory is not limited to the familiar 3 dimensions of space and 1 dimension of time. It requires additional spatial dimensions, up to 10 or even 11 in some formulations, to be mathematically consistent. These extra dimensions are typically compactified, meaning they are curled up and hidden from our everyday perception. Enter M theory, a unifying theory proposed in the mid-1990s that aims to combine the various versions of string theory into a single framework. M theory suggests that our universe is a 3-dimensional brain floating in a higher dimensional space. Other brains could exist in this higher dimensional space, each representing a different universe with its own distinct properties. These brains can collide, separate, and interact in ways that might give rise to new universes, further supporting the idea of a multiverse. Anthropic principle, the fine-tuning argument. The anthropic principle is often invoked in discussions of the multiverse to address the apparent fine-tuning of our universe. It observes that certain fundamental constants of nature, such as the strength of the gravitational force, the charge of the electron, and the cosmological constant, appear to be precisely calibrated to allow for the existence of life as we know it. Even slight variations in these constants could render the universe inhospitable to life. In a single universe scenario, this fine-tuning might seem extraordinarily improbable, leading some to speculate about the involvement of a designer or an underlying principle we do not yet understand. However, the anthropic principle offers an alternative explanation when considered within the context of the multiverse. If there are countless universes, each with different values for these fundamental constants, it's not surprising that at least one universe, ours, has the right conditions for life. This shifts the question from why is our universe fine-tuned to why wouldn't there be a universe like ours in a vast multiverse? Critics argue that the anthropic principle is a tautology, offering no predictive power or testable hypotheses. However, it does provide a compelling philosophical framework for understanding the multiverse. By suggesting that our universe is one of many, it offers a potential explanation for the fine-tuning problem without invoking supernatural or highly speculative mechanisms. Quantum mechanics and many worlds interpretation. Another significant contribution to the multiverse theory comes from the realm of quantum mechanics, specifically the many worlds interpretation, MWI, proposed by physicist Hugh Everett in 1957. Quantum mechanics describes the behavior of particles at the smallest scales, where the rules of classical physics no longer apply. One of its most perplexing features is the concept of superposition, where particles can exist in multiple states simultaneously until observed or measured. The MY takes this concept to its logical extreme. It posits that every possible outcome of a quantum event actually occurs, but in separate, branching universes. Whenever a quantum event with multiple possible outcomes happens, the universe splits into multiple versions, each representing a different outcome. This interpretation suggests that there is a vast, constantly branching multiverse, where every possible history and future of our universe exists simultaneously. While the MY remains controversial and lacks direct experimental evidence, it provides a provocative theoretical basis for the multiverse. It challenges our understanding of reality and encourages us to consider the possibility that our universe is just one branch among an infinite number of parallel realities. Cosmic landscape and the string theory multiverse. The idea of a cosmic landscape further extends the multiverse concept within the framework of string theory. The term was popularized by physicist Leonard Susskind, who used it to describe the multitude of possible vacuum states in string theory. Each vacuum state corresponds to a different set of physical laws and constants, potentially leading to a different universe. In string theory, the equations allow for a vast number of possible solutions, each representing a different way that the extra dimensions could be compactified. This leads to the notion of a landscape of possible universes, each with its own unique properties. The cosmic landscape is not just a theoretical construct. It is a mathematical prediction of string theory that suggests our universe is one of many possible configurations. The vastness of the cosmic landscape raises profound questions about the nature of reality and our place within it. It suggests that the universe we observe is just one of many, each with its own distinct characteristics. This perspective aligns with the multiverse theory and provides a rich framework for exploring the implications of living in a multiverse. the search for evidence, challenges, and prospects. While the theoretical foundations of the multiverse are intriguing, the search for empirical evidence remains a significant challenge. Observing or interacting with other universes is currently beyond our technological capabilities, leading some to question the scientific validity of the multiverse theory. However, researchers are exploring indirect ways to test the theory. One approach involves looking for signatures of cosmic inflation in the comb. Patterns or anomalies in the comb could provide hints of interactions with other universes. Additionally, advancements in particle physics and experiments at facilities like the Large Hadron Collider could uncover phenomena that are best explained by the existence of extra dimensions or other universes. Another intriguing possibility is the detection of gravitational waves, ripples in space-time caused by violent cosmic events. If multiple universes exist, their interactions might leave detectable imprints in the form of gravitational waves. Ongoing and future experiments in gravitational wave astronomy could provide valuable insights into the multiverse theory. Conclusion: a theory in progress. The birth of the multiverse theory is a testament to the power of human imagination and the relentless pursuit of understanding. From the inflationary theory of the Big Bang to the complexities of string theory and the philosophical implications of the anthropic principle, the multiverse theory challenges us to think beyond the boundaries of our observable universe. While empirical evidence remains elusive, the multiverse continues to inspire and provoke, driving scientific inquiry into the fundamental nature of reality. As we advance our theoretical models and technological capabilities, we may yet uncover clues that bring us closer to answering one of the most profound questions in science. Are we alone in our universe, or are we part of a vast, interconnected multiverse?